In this lesson, we're going to take a look at dividing using partial quotients. Now, when we've done the area model and the distributive property for division, we're pretty much using partial quotients to divide. It's just a different way that we're going to represent division. So here we have a problem, 184 divided by 8. Now, we're used to seeing these problems like this. It means the same thing. The only difference here is that our dividend is inside of our house instead of the first number. But we would read this problem as 184 divided by 8, even though the number 8 comes first. Now, when we were solving using our area model, what we would do is draw our rectangle. We would have 184 off to the side, and we'd bring our 8 on this side, and then we would think about things that we could multiply times 8 that are going to get us close to 184, but don't bring us over. So maybe we would start with something like 8 times 10, because I know that 8 times 10 is going to get me 80, and I would then subtract 80 from my whole over here, and I'd be left with 104. And then I can pull another 80 out of that, so 8 times 10 is going to get me 80, and I'm going to subtract 80 more from over here, and I'm going to end up with 24. And then I know that 8 times 3 gets me 24, and then I'd subtract my 24, and I'd be left with 0. To find my quotient, I would take my numbers on top, add them up, and I'd be left with 23. Now, what we're about to do for partial quotients pretty much follows the same exact steps. The only difference, instead of drawing it as a rectangle and putting numbers on top, we're going to put some numbers off to the side. So to start off with our partial quotients, we're going to do the same exact thing we just did with our area model. We're going to think about multiplication. 8 times something is going to get me a number. Then I'm going to subtract that from my total. So I'm going to go ahead and start with 8 times 10. 8 times 10 gets me 80. I'm going to take this 80 here and bring it underneath and subtract it from my whole. So instead of having to write my whole off to the side, here I can just do some subtraction. So when I subtract 184 minus 80, I'm left with 104. Now I'm going to put another multiplication problem next to it. Again, I'm going to do 8 times 10 because I know that's going to get me 80 again. And I'm going to subtract 80 from my whole. When I do that, I'm left with 24. Now I'm going to go ahead and multiply my 8 times 3 because that's going to give me 24. And I'm going to subtract my 24 here, and I'm left with 0. In order for me to get my quotient, I'm going to put a box around all of these factors that I have. Same concept as when I circled all of the numbers on top of my rectangle that I did with my area model. Here I'm just going to go ahead and make my box, and I'm going to add down. So 10 plus 10 plus 3 gives me 23. And then I'm going to take this 23 and I'm going to place it on top of my house. So my answer is 23. So again, it's pretty much identical to our area model and to our distributive property. This is just a vertical method instead of a horizontal method. This method is very similar to what we're going to be doing in terms of long division. It looks very similar to long division, and this is definitely a way to go for some of you who aren't so strong with your multiplication facts, because when we're doing partial quotients or when we're using the area model for division, we don't have to be perfect with our division. It's okay if it takes us a little bit longer to get to that answer. We're still going to get there. Let's take a look at another problem. Here we have 203 divided by 7, and we're going to go ahead and we're going to demonstrate it as area model and then as partial quotient so we can make sure we're understanding that connection. So I'm going to write my problem up here, 203 divided by 7, and I'm going to go ahead and draw my rectangle for my area model, and I'm going to put my 203 off to the side so I can do some subtraction, and my 7 would go over here. 7 times what is going to take a big chunk out of 203? Maybe you just want to go with 7 times 10, so that's fine. 7 times 10 gets me 70. I'm going to subtract 70 from my whole, and when I do that, I'm going to be left with 133, and I can take another 70 out of that, so I'm going to multiply 7 times 10, and that's going to give me 70, so then I can subtract there. I'm going to go ahead and borrow from that 0, and then I have 63. 7 times what gets me 63? 7 times 9, so I'm going to put my 9 up here, and I have 63, and I'm going to subtract and I'm left with 0. To find my quotient, I would add all of my partial quotients up, and I'd get 29. Now, using my partial quotients method, it's the same concept, except I'm doing this vertically now instead of horizontally. So again, I want to take a piece out of 203. So I'm going to go ahead and I'm going to multiply 7 times 20 off to the side here, and that's going to get me 140. Now I'm going to subtract 140 from my whole. And when I do that, I'm left with 63. Then I need to think 7 times what gives me 63? Well, 7 times 9 gives me 63. And I'm going to subtract 63 from my whole, and I'm left with 0. My final step is for me to take a box around all of my partial quotients and add them up. And I have 29 as my final quotient. So there we have partial quotients. I want you to give this next problem a try. 312 divided by 6. Go ahead and use partial quotients, and then you can always check your work with either the area model of division or distributive property of division. There are quite a few ways that we could have broken this problem up. I'm going to go ahead and I'm going to start. Let's just say I wanted to start with 6 times 20. I know that's going to be less than 312, and that's going to get me a good start. 6 times 20, I'm going to take away 120 from my whole. So when I do this, I can borrow, and I have to do some subtraction, and that's okay. And now I'm left with 192. Well, my 120 there, I can take away another 120. Nothing's going to stop me from doing that. So I'm going to go ahead and I'm going to multiply 6 times 20 again, and that gives me another 120. So I'm going to go ahead and subtract another 120. And when I do that, I'm left with 72. 72 is still pretty big, but I do know that 6 times 10 gets me 60, and that's pretty close to 72. So now I can subtract 60, and I'm left with 12. And there's a fact that I know. 6 times 2 is going to be equal to 12, so I'm going to subtract 12, and I'm left with 0. Now this is a great way for us to work these problems out. Take away piece by piece. Notice, I'm using multiples of 10. I know those multiples, I know those basic facts pretty well, so using my multiples of 10 is a surefire way that I'm going to get to my answer eventually. Sometimes it's going to take longer than other times, but that's fine. My last step is to put my box around those factors and then add them all up. 20 plus 20 is 40, plus 10 is 50, plus 2 is 52. And that is my final quotient. You might have broken your problem up different, but I bet you got 42 nonetheless. All right, here is our next problem. I want you to work this one out using partial quotients. 370 divided by 5. Go ahead and give this one a shot. With this problem, I want to see if I can take a really big chunk out of it. So I'm going to look at my 3 in my hundreds place, and I'm really going to look at it like it's 30. I know that 5 times something is going to give me 30. So I'm going to think, well, 5 times what gives me 30? 5 times 6 gives me 30. 5 times 6 isn't a lot, though. That's only 30. So I'm going to change it to 300. So 5 times 6 gives me 60, gives me 300. So now I can subtract 300 from my 370, and now all I'm left with is 70. I'm going to go ahead and multiply 5 times 10, and I have 50 there. Again, taking another big chunk out of my 70. And now all I have left is 20. 5 times 4 gives me 20. I'm going to subtract that 20, and I'm left with 0. My final step is just to add all of those factors up. So all of my partial quotients. 60 plus 10 gives me 70, plus 4 gives me 74 as my final quotient to this problem. You might have broken yours up a different way. Maybe you went with 5 times 10 all the way down until you got rid of everything. Maybe you started with 5 times 70. Doesn't matter how we start, as long as we're continuing to take bits and pieces away from our total, our dividend. Next problem. Go ahead and solve this problem. We have 384 divided by 8. Use partial quotients to find your quotient. I want to start with something maybe not so big, but that's okay. I know that if I were to multiply 8 times 50, that's going to be too much because 8 times 50 is 400, so I can't go that high. But maybe I'm pretty comfortable with 8 times 30. That's going to give me 240, so I can subtract 240 from my whole, and that's going to take a pretty big chunk out of my number. I'm left with 144, which doesn't look so friendly, but I know that 8 times 10 gives me 80, and that's a pretty easy fact for me to know. And then all I have to do is do some subtraction, and I'm left with 64. Maybe I don't remember that 8 times 8 gives me 64, but I do remember that 8 times 5 gives me 40. So I can subtract 40 away, and I'm left with 24. I know that 8 times 3 is equal to 24. I can subtract, and I'm left with 0 down here. All I have left to do is add up all of my partial quotients off to my side, and that will answer my quotient. 30 plus 10 is 40, and then 5 plus 3 is 8, so 40 plus 8 gives me 48 as my final quotient. So again, partial quotients, we're just taking bits and pieces away from our number until we're left with 0 or something that's less than my divisor. All right, go ahead and solve this word problem. Mr. Laster spent $168 on 7 gifts for the holidays. How much did he spend on each gift if each gift costs the same amount? Go ahead and solve this problem. If I were solving this problem, I'd have 168 divided by 7, and maybe I want to use the area model, or maybe I want to use partial quotients for this. I'm going to go ahead and use partial quotients just because that's what we're working on right now. I'm going to go and start breaking my number apart. I know that 7 times 10 gives me 70. I'm going to subtract 70 from my whole, and I'm left with 98. I'm going to pull another 7 times 10 out of there, gives me 70. Subtract that 70, and now I'm left with 28. And 7 times 4 is equal to 28. I subtract my 28, and I'm left with 0. My final step is to put a box around all of my partial quotients and add them up, and I have 24 as my final quotient. So my question says, how much did he spend on each gift if each gift cost the same amount? He spent $24 on each. All right, let's look at our last problem of the day. I want you to give this problem a try. I know it's a big number, but use the same concepts that we've just been talking about to solve this problem. You may use area model or distributive property or partial quotients to solve, but I want to see you break this number apart into smaller pieces and see if you can get this quotient. This one's hard. All right, I'm going to go ahead, because we're doing partial quotients, and use partial quotients to solve this problem. I'm going to have my 6 on my outside, my divisor, and then my 1,248 is going to go on the inside of my house. And I'm going to start to take bits and pieces away from this. Now, 1,248 might look intimidating, but I do know that I can take big pieces out by doing something like 6 times 100. 6 times 100 gives me 600. That's a really big piece that I can take away from this problem. When I subtract, I'm left with 648. I can do another 6 times 100 to take another really big piece out of this problem. I subtract, and all I'm left with now is 48, which is super manageable for me. Maybe I don't remember what gets me to 48, but I do remember that 6 times 4 gets me to 24. I'm going to subtract 24, and I'm left with 24, and then so 6 times 4 again gets me 24, and I'm left with 0. My final step is to add up all of my partial quotients. 100 plus 100 is 200, and 4 plus 4 is 8. So I have 208 as my quotient. So even with our really big problems, we can chip away at it piece by piece by piece. Think about facts that you know, and you can get your quotient. All right, that's our lesson for today. Tomorrow we're going to be looking at larger numbers and start to do some long division using the standard algorithm that your parents learned, but you can always go back to partial quotients to help you out. See you then.